All of the SED commands we've looked at so far are applied equally to every line in the file. But suppose you only want to affect certain lines. To do this, you can preface any SED command with an address. An address can be a line number, specifying a line, a $, specifying the end of the file, a pattern, enclosed in slashes, specifying lines matching the pattern, or a pair of addresses, separated by a comma, representing the range of lines from one to the other inclusive. You can also use an exclamation point to specify all lines not matching the address. We'll cover that later. Some commands cannot accept a range. I'll mention those when they come up. So for example, if you wanted to change up to all caps on line 3, but not any of the other places it occurs in the file, you could do so by prefacing the S command with the address, or line number, 3, like this. We'll do sed line number 3, change lowercase up to uppercase in dukeofyork.txt. So the address, or line number 3, precedes the S command. In this case, it causes the up to be changed to uppercase only on line 3 and not in any of the other lines it appears in the file. In the rest of this lesson, we'll discuss some additional SED commands which can be used with addresses. P prints the specified lines, D deletes the specified lines, R reads a file at the specified line, W writes the specified lines to a file, and Y transforms characters on the specified line in the same way that tr command does. The P command simply prints any line to which it is applied. If used without the -n flag, which suppresses the default behavior of printing each line after all substitutions have been applied, it doubles every line. For example, we can say sed p dukeofyork.txt. So the P command here is used in place of the S command that we've been using before this. So the P command being applied to every line in addition to the default of printing each line means that every line is printed twice, once by default and once by the P command. If you use the P command together with the N flag, it simply prints every line. We'll use the -n flag to suppress the default printing of each line, and then a P command to print each line. The result is simply to print each line. Well, we could have used cat for that. Neither of these commands is particularly interesting, but when used together with an address, P becomes one of SED's most frequently used commands. If you preface the P command with an address, it prints the line or lines specified by that address. For example, we'll use the -n flag to suppress the default printing. We'll print line 3, that is to say, apply the address 3 to the P command of dukeofyork.txt. This prints only the third line of the file. You can print the last line of the file with $P. In this case, we've had to quote the command because it contains a $, which is special to the shell. So this command, $P, prints the last line of the file even though we don't know its line number. There is no special character for the first line of the file. If you want to print the first line of the file, you just say 1p, dukeofyork.txt. And you can use a range of line numbers separated by a comma, in which case it prints those lines inclusively. We can use 2, 4p to print the second through the fourth lines of dukeofyork.txt. You can use whitespace to separate the address from the command to improve readability. For example, space. This prints lines 1 through 3 inclusive. The space, I think, makes things a little bit easier to read, but is often left out. If you specify multiple input files, SED treats them as though you had put them together with one big file with cat. For example, here's the file array.c. If you use both dukeofyork.txt, which has 8 lines, and array.c as input files to SED, the first line of array.c is treated as the 9th line of the input. Clear. So we can say sed -n will print lines 8 through 9, taking dukeofyork.txt and array.c as inputs. This prints the last line, or 8th line, of dukeofyork.txt, and the following line of the input, line 9, which is the first line of array.c. You can also use a $, to specify the last line of the last file. So we could, for example, say sed -n $P will take dukeofyork.txt and array.c. This does not print the last line of each file. It cats the two files together and prints the last line of the total. An address can also be a regular expression surrounded by slashes. For example, to print only lines containing lowercase down, you could use sed-n /down/p. Or, to print only lines containing a capitalized or lowercase they or them, you could use sed-n to suppress printing, and then we'll use the pattern uppercase T or lowercase t, followed by HE, followed by M or Y, and print it. What this does is it looks for any line containing a capital or lowercase t, an HE, and then an M or a Y, which is to say either capital they or them, or lowercase they or them, and print that. So this is only the lines that contain they or them, whether it's capitalized or not. If a regular expression contains a slash, which would usually delimit the end of the regular expression, you must escape it with a backslash. So for example, if you were looking for the phrase and or, you would have to do it like this. Backslash escapes the special meaning of the slash. So this is looking for and/or in the file dukeofyork.txt and prints only those lines that contain it. As you can see, there aren't any of them. As with line numbers, you can use a pair of patterns separated by a comma to specify a range of lines. When you use a range of patterns, it specifies every line from the first line found containing the first pattern to the first line found after that containing the second pattern, inclusive. I'll use the NL command to number the lines and make this clearer. So NL shows that the dukeofyork.txt has 8 lines in addition to his 10,000 men, and this is what they are. So if we number the file and then print only those lines from the first line containing marched to the first subsequent line containing when, and print them. So again, what this does is it numbers the lines of dukeofyork.txt and then prints only those lines from marched to when. It starts printing with the first occurrence of marched in the file on line 3, and keeps printing until it finds when on line 5. Even though there are additional occurrences of when on line 6 and 7. Remember, when you use a range of regular expressions, it prints until the first occurrence of the second expression after the first expression. SED does not start looking for the second pattern until after the first pattern is matched. If the second pattern is not found on a subsequent line, it just keeps printing until the end of the file. So for example, if instead of printing from marched to when, we print from when to marched. In this case, it starts printing the first time it finds the word when on line 5. But because it doesn't find the word marched after that, it just keeps printing until it runs out of file. If the second pattern happens to occur in the same line as the first pattern and is ignored, again, the range continues until the second pattern is found on a subsequent line. For example, we'll line number dukeofyork.txt, and we'll print only those lines from hill to up. In this case, the words hill and up both occur in line 3, but the up in line 3 does not terminate printing. It keeps going until it finds the next occurrence of up on a subsequent line on line 5. A range of patterns can match multiple sections of a file. For example, we'll print anywhere from a letter G to a letter H and print those. Now, this uses a pattern that starts with any line containing the letter G and stops at the next subsequent line containing the letter H. You can see what it does. It starts printing when it finds the G in grand on line 1, and stops printing when it finds the H in had on line 2. But then it starts again with the G in again on line 4, and stops again with the H in when on line 5. Here's a more practical example for programmers. As you see, the sample file array.c is a C program in which it uses the convention that each function begins with an opening brace at the beginning of a line and ends with a closing brace at the end of a line. Let's take a look at this sed command. We will print from that to that. Now what this does is it starts printing when it finds a close brace at the beginning of a line, and stops printing when it finds an open brace at the beginning of the line. In other words, it skips the body of each function and prints only the comments and declarations in between them. You could swap those two patterns to print only the function bodies, but I think this is an interesting thing to do if you want to get a sense of what's happening in a file. An address can include a mix of line numbers, patterns, and $signs. For example, we'll take a look at dukeofyork.txt line by line. We'll print that only from line 2 to the first line containing down. So this is a mix of a line number and a regular expression. Alternatively, you could print from the first line containing when to the end of the file. Finally, you can reverse the effect of an address by following the address with an exclamation point. Or, to put it another way, you can reverse the effect of a command by preceding the command with an exclamation point. For example, if this sed command, 2,5p, prints lines 2 through 5, adding an exclamation point doesn't print lines 2 through 5, or alternatively, it prints all lines other than 2 through 5. Similarly, specifying a pattern followed by an exclamation point prints all the lines that do not contain down, or alternatively, does not print lines that do contain down. You can think of it either way. Another sed command that is much more interesting when used with an address or addresses is d, which deletes the specified line or lines. I'll use the nl command again to number the lines and make it clearer what's going on. For example, if we say 4d, this deletes line 4. You could also delete all lines containing up, or you could delete all lines containing 1000 to lines containing down. So that last command deletes from the first occurrence of 1000 to the next subsequent occurrence of down, inclusive. The d command is often used with the exclamation point modifier. For example, we'll delete from only lines that do not contain the word up. Or we could specify lines 2 through 4, use the exclamation point to invert it. This deletes everything except lines 2 through 4, which is the same as printing lines 2 through 4. You can use the p command to check which lines an address or addresses will affect, then change the p to d to perform the deletion. Keep in mind, though, that as with s, the d command only affects sed's output, not the original file. Even if you delete nearly every line in the file, for example, we can delete lines 1 through 7 in dukeofyork.txt, leaving only one line, but even after that deletion, the original file, dukeofyork.txt, is still exactly the same as it was. The sed command r reads in another file immediately following the specified line. So I'll just create a file called haha, and we'll make it fairly obvious. Say, put it in all caps, say haha, he said down. So we can say, at the line down, read the file haha that we just created. So what this does is it looks for any line containing the word down, and at that line it will read in the contents of the file haha. The space between the R and the following file name is optional, but note that in some versions of sed you can use at most one space. Note that the R command is one of those that cannot be used with a range of addresses. It can only be used with a single line number, pattern, or a $sign indicating the end of the input. The related W command writes the specified line or lines to a file. This is an addition to the default behavior of printing each line, after any processing, to the standard output. For example, we can take lines 1 through 3 and write them to the file top. So this command writes the first 3 lines of dukeofyork.txt to the file top, in addition to performing the default action of printing each line to standard output. So now when we cat the file top, you see it contains lines 1 through 3 of the Duke of York file. You can use the -n flag to suppress that display. For example, we'll use the -n flag to suppress that default printing, and we'll look for lines containing down and write them to the file called down. In this case, it produces no output on the screen, but it writes any lines from dukeofyork.txt that contain down to the file down. As with the R command, the space between the W and the following file name is optional, and in some versions of SED you can use at most one space. In addition to the W command, you can use a W modifier on the S command, which causes the modified line or lines to be written to the specified file. And again, this is in addition to the default of printing the lines to the standard output. For example, we'll change up to uppercase and write it to the file up. So this command will perform the usual substitution of lowercase to uppercase up, and in addition will write the modified lines to the file called up. So in this case, you see that the standard output on the terminal includes every line of the file, whether it's modified or not, whereas the file up includes only the modified lines. The W modifier can be combined with the G and/or P modifiers, but if you do use W together with another modifier, it has to be the last one. For example, we'll change up to uppercase globally and write it to the file up. This changes every lowercase up to uppercase. The G modifier causes that to apply even if there are multiple ups on the line. And in addition, it writes the modifications, including multiple modifications per line, to the file up. However, if you try to put the W and G options in the other order, change up to up, do it globally to up. Now you might think that this will write to up and do it globally, but it doesn't actually do what you wanted it to. You can see that there are multiple ups in some lines, and it only changes the first one on each line, and it writes each modified line to the file called G space up. Because the G is considered part of the file name, it only changes the first up in each line to all caps. So if we cat G space up, you can see that it contains the output, but there's only one substitution on each line, because the G was treated as part of the file name. If you use W together with another flag, it has to be the last one. One interesting property of the W command and modifier is that they write the line immediately when SED executes the W or S command. This is different from the default display to standard output, which is only performed after all commands applying to the line have been executed. For example, let's take a look at this command. We'll use -e to specify multiple SED commands in a single command line. On lines containing down, we'll write them to the file called down. And we will also change up to up. The first command in this instance, the W command, writes every line containing the word down to the file called down. And the second command changes the first lowercase up on each line to all caps. This means that in the output on the screen, you see up capitalized in the last line. But in the file down, it is not. That's because the line was written before the S command was executed. If you put the two commands in the opposite order, the up is capitalized before the W command is executed, so the modified line appears in the file down. Unlike the previous execution, you see that the word up is capitalized on the last line, whereas in the previous command it was not. Similarly, if we did this, we'll change up to uppercase and write it to the file out, and then we will also change down to uppercase and write it to the file out. This command writes to the file out after each S command is executed, which means that although in the standard output you see the up and the down transformations mean each line is printed only once, in the file out, you see that the last line, which contains both up and down, was printed once by the first command, which changed up to up, and then again by the second command, which changed down to uppercase. The first time a W command or modifier is executed, it creates the file if it doesn't exist, or deletes its contents if it already exists. This does require the appropriate permissions on the specified file to directory, of course. Any subsequent Ws mentioning the same file append the specified line or lines to the file. This means that the file remains open from the first time it is mentioned to the end of the current run of sed. Some versions of sed have a maximum number of files you can have open at once in this way, typically 10. Sed's Y command is similar to the Unix command tr. It replaces single characters with other single characters. The Y command takes two strings of characters separated by slashes as arguments, and whenever it finds a character in the first string, it replaces it with the corresponding character in the second string. For example, Y command will change A, B, C, D, E, and F to their uppercase equivalents. So the Y command takes each character from its first string and replaces it with the corresponding character in the second string. This changes lowercase a, b, c, d, e, and f to uppercase, and the result looks rather like a ransom note. Or to change the Grand Old Duke of York into leet speak, you could use this. We'll change A, C, E, I, L-O-S-T to A, C, E, I, L-O-S-T. So this replaces A with 4, C with parenthesis, E with 3, I with exclamation point, L with 1, O with 0, S to $, and T to plus. Note that there is no way to restrict the effect of the Y command to only part of a line. It's all or nothing. Also note that unlike tr, the Y command does not let you specify a range of characters. If you do this, unfortunately, it does not specify the range of characters A through Z, it only specifies A hyphen and Z, replacing lowercase a hyphen and Z with uppercase A hyphen and Z. The uppercase hyphen, of course, looks exactly like the lowercase one. In fact, the only thing you can do in the Y command other than specify an ordinary printing character is you can use a backslash. Backslash n specifies a new line, backslash slash specifies a slash, and backslash backslash specifies a backslash. So for example, we could transform A, C, and D to new line, slash, and backslash, respectively. So all the A's have become new lines, all the C's have become slashes, and all the D's have become backslashes. I used ACD rather than ABC because there are no B's in this file. In this video, we'll discuss commands that affect multiple entire lines. A appends lines, I inserts lines, and C changes lines. Every command I've shown you so far affects only one line at a time, but sed's A, I, and C commands append, insert, or change one or more entire lines at the same time. However, sed is still inherently line-oriented, so whenever you use these three sed commands, you must use \newline to mark the beginning of the new line or lines. This is in addition to the fact that if you use any of these commands on the shell command line, you must use quoting or some other form of escape to protect the new line from the shell. The basic A command appends one or more lines of text after the single line specified by its address. Here's how it looks in action. On lines containing down, we will append a line that looks like this. So this A command has the same effect as the R command we looked at earlier. It appends an infantile comment after each line containing the word down. Now let's look at that command in a little more detail. The A command is preceded by a regular expression that matches any line containing the word down. A is one of the commands that requires its address to match a single line, not a range. The A must then be followed by a backslash to escape the following new line. The backslash is required, and even though you can't see it on the screen, there must not be any spaces or tabs between the backslash and the following new line. The line after the A command is the text to be appended. And then there is another new line which is not escaped. You can see it by the fact that the quote that ends the command is the first thing on the following line right before dukeofyork.txt. This new line makes the appended text appear as a line by itself. If you leave that out, the appended text appears at the beginning of the following line instead. Now this might be exactly what you want. Let's see how that works. On lines containing down, we will add, he said down. And then in this case, we will not put a new line. We'll just put the closing single quote right there. So in this case, you see the appended text is stuck right in the beginning of the following line. And again, this might be exactly what you want. You can also append multiple lines. Each new line within the appended text must be escaped. So for example, on lines containing down, we can append again, escape the new line. And this last new line, we do not escape, although we can. So in this case, every time we see the word down, it'll append 2 lines. You can omit the address, in which case the text is appended after every line. Here's a useful example. On every line, we will append a blank line, escaping the new line in our Duke of York .txt file. This has the effect of double spacing the file. If there's any white space at the beginning of an appended line, some versions of SED remove it. For example, on lines containing down, we'll append white space, he said down. We'll do that to Duke of York .txt. And you see here the white space was removed. This is done to make scripts that use the A command easier to read by allowing indentation in the script which does not affect the output. You can prevent this from occurring by putting a backslash before the white space. So on lines containing down, we will append backslash white space. He said down. In this case, the white space is preserved. Because of the difficulties of dealing with new lines within shell commands, the A command is most often used in SED scripts rather than on the command line. For example, we can make a script, and we'll change on lines containing down, we'll append, he said down, and then on lines containing up, we'll append, he said up. So when we execute that script, it applies both A commands. The I command is exactly the same as A, except that it inserts the lines before the specified line rather than appending after. For example, we'll make a script, and on lines containing again, we will insert a comment. And then another command in the same script, on lines containing again, we will append a different comment. So when we execute that script, the I command inserts a line before the line containing again. The A command then appends a line after the line containing again. Finally, the C command replaces the specified line or lines, unlike A or I, C accepts a range of lines, with new text. For example, from lines containing top to lines containing again, we will change, he treated them inconsistently, escape the new line, and their moods were variable, new line. So this replaces from the first line containing top to the next subsequent line containing again. With the new lines, he treated them inconsistently and their moods were variable.